started. Okay, so hopefully you picked up a paper and it says dry mix on it, which probably doesn't make any sense to you right now.
No, I thought
But it should after this. Okay, we're going to use the 3 days this week to kind of slowly get into what's going to be expected of you as far as physics goes and reading graphs and things like that, okay? So what dry mix is it's an easy way for us to determine what's a dependent variable and what's an independent variable, okay? It's a good acronym to use if you're ever confused, because those are two variables that you do not want to get confused once we start graphing our findings and things like that. I'm going to actually write this a little bit bigger so that I can show you some things. Okay, so anything that I write up here, I want you to write on your paper, okay? That's usually how I do these things. You're kind of responsible for whatever you write down, but I recommend writing down what I do. Yes?
Okay, so what if science is like your most weakest course? There's no such thing as stupid questions,
Right.
Okay.
That's fine. Okay, so this whole thing, our 7.1 notes that we're starting today is all about dependent and independent, like I said. So what do you think dry is going to help us with? Which one of those two?
Dry.
Dependent, because it starts with a D, right? Okay, so for dry, our D stands for dependent. Our R is going to be responding. And our Y tells us that it's going to be on the Y-axis. Okay, that's what dry stands for. Dependent, responding, and Y-axis. So let's talk about each of those three in a little bit more detail so that you know what I mean. Okay? So a good question to ask yourself when you're trying to figure out an experiment and which is what as far as dependent variables go, a good question to ask yourself, and I want you to write this down on your paper, is what is the experiment trying to find or solve? Okay? And if you can easily answer that question, then you have found your dependent variable. Okay? So the R says responding. Okay? So that's going to be the variable that's responding to your experiment. Okay? So say that I have an experiment and I want to see what type of fertilizer works best on my flower, my rose bush. Okay? So I'm going to change my different types of fertilizers, right? What am I going to see as a result of that? What am I looking for in that type of experiment that is the result or that's responding to those fertilizers? How do I see which one works?
Which one's healthier or grows faster?
Okay, which fertilizer produces the biggest rose bush, right? Okay, so in that situation, I'm asking myself, what's the experiment trying to find? It's trying to find what type of fertilizer works best on rose bushes, okay? And I'm trying to figure out what's going to grow the best. So my dependent variable on this is going to be which rose bush grows the biggest. Okay, that's what the experiment's trying to find, is the best growing rose bush. So that would be my dependent variable. Okay? Another way that you can think of a dependent variable using this R right here is you're looking for the result. Okay? Whatever the result that you're trying to get to is going to be your dependent variable. Okay? And then lastly, this Y, the Y-axis, does it go up and down or left and right? Up and down, okay? And the easiest way to remember that is the way I've written this Y, is it goes up and down. So that's my Y-axis. Okay, the Y-axis is the vertical axis. Okay, now let's look at our word mix. I'm going to switch colors here. Okay, so we have M, which is going to stand for manipulated. I stands for independent. And X stands for what, do you think?
X-axis.
The x-axis, yes. Okay, so mix helps us understand our independent variables because there's an I in there. Okay, so manipulated, independent, and the x-axis. Okay, we're going to do the same sort of thing that we did for dry, and I'm going to start by writing a question you can ask to help you figure out the independent variable. And this question asks, what do you change during the experiment? What do you change during the experiment? What do you change during the experiment? Okay, so if I go back to my rosebush example, I am using different fertilizers to figure out which one works the best. What part of that experiment am I changing?
The fertilizer.
The type of fertilizer. Okay, so that would be my independent variable in that situation because I'm changing the fertilizer. Am I just going to use water? Am I going to use this high dollar fertilizer I got from Lowe's? Okay, am I going to use water and sugar? Okay, I change what I'm feeding that rose bush, so that would be my independent variable. Okay, another way to remember which one is your independent, if I look closer at this I right here, it also tells me that it's whatever I control. So I'm controlling how much water and food the rose bush gets. I can't control how it grows, right? That's not up to me. Okay, that's up to the rose bush and the nutrients it's getting. I'm controlling how much fertilizer and what kind of fertilizer it's getting. So that would be the independent variable, is the fertilizer. Okay? And then this X is the x-axis. Think of that as like an arrow. Okay, the x-axis is the horizontal one. It goes left to right. Okay, and that is our dry mix. Okay, I have to erase this to make more room on my board. But that was all up here. I'm about to write information below dry mix. Okay, so what I'm about to write on the board is going to go below our dry mix right there. And we're going to fill in that graph in the bottom right corner as well. So give me a second. Let me erase this. Okay, we're going to write an example down there and kind of practice using our acronym dry mix to help us out. All right, I want you to write this example for me. Okay, so our example. An experiment measured how far a bowling ball travels when released from ramps at different angles. Okay, so that's the experiment, the investigation that we're looking at. An experiment measured how far a bowling ball travels when released from ramps at different angles. So what we need to be able to do is, looking at an experiment like this, we got to be able to determine what part of that experiment would be considered the dependent variable and what part of that experiment would be considered the independent variable. Now, what I'd like to do first when I'm doing these is, it's easier for me to do the independent variable first. Okay, so I like to start with this one. If your brain works differently and you want to start with dependent, go for it. Okay, but in my opinion, it's easier for me to find this one first, and then I can kind of determine after that what would my dependent variable be. Okay, so what I like to use for my mix acronym is the I control. Okay, that helps me understand what part of the experiment is independent. So what part of that experiment, if I were to do this, what would I be controlling?
When you release the ball.
Yes, but more specifically, what about when I release the ball? What ramp I use. Okay, I can use a really steep ramp. I can crank it down a notch and it's not as steep. Okay, I can use a really, what's the opposite of steep? Level. I can use a really level ramp. Is that opposite of steep?
Probably like incline.
Yeah, that's weird. Okay, never thought of that. Okay, but I'm controlling, in this experiment, I control what ramp I use. Okay, so whatever I control is my independent variable. So I'm going to put a ramp angle as my independent variable. Because that is what I am controlling.
The opposite of steep is gentle.
Is what?
It says gentle or reasonable.
So
And
gentle.
I'm not 100% sure.
Well, okay then.
How correct Google is.
See, Google and right.
Okay, now I asked myself about the dependent variable. Remember, this is our dry portion, and the R stands for responding or result. So what would be the result be of dropping a bowling ball at different angles?
How far it
Fast
falls.
it goes or how far it goes.
How fast or how far it travels. Okay, this experiment measured distance, how far. So that would be my dependent variable is how far the ball travels. Okay, so I like to work backwards like that. I do my independent before my dependent, and it just kind of helps me out. Maybe I'm weird, I don't know, but I'm your teacher, and that's how I choose to teach you, so you're welcome. Okay, last thing that we're going to do on this note page is fill out, you have a little portion of a graph down here. Okay, it's already drawn for you. We're just going to draw where these would go on a graph if you were required to graph this information. Okay, so which one of these is the y-axis? The one pointing up. So this is my y-axis. This is my x-axis. Which one is going to go on my y? Think about dry. What does D stand for?
Dependent.
The dependent variable. Okay, so my y-axis, I have my dependent variable. Yes, this one would be the independent variable. Okay, and we're going to talk more about graphing tomorrow. So, keep this paper because, as you can tell, I have stuff written on the back of mine. We're going to be doing the back tomorrow. There's nothing written on yours, but we're going to fill it in tomorrow, so keep this, okay? Now, I need you to log into Canvas, and you're going to do the 7.1a assignment. Let me show you. So back on that home page, okay, 7.1a assignment, you're going to read these different experiments and tell me what would the independent variable be and the dependent variable be. Sound good? Awesome.